Hey guys, Mr. Davis here. Having a little trouble with the camera tonight, so what I want to do is go ahead and see if I can get through this presentation about the hydrosphere quickly. So it's just going to be a voiceover on this one, but that's okay. I'll still be able to go ahead and cover this information for you. All right, so the next section that we need to talk about is going to be the hydrosphere, as I said. Now, the hydrosphere is all of the water that is on and around Earth's surface and even in Earth's surface. So the geosphere is the rocks and then the magma under the surface and everything like that. The hydrosphere is the water. All right. So let's go over a couple of objectives of what we're going to have for what we want to be able to do as we go through this system. So we first want to be able to name the major processes of the water cycle. Then we want to be able to describe the properties of ocean water. Be able to describe, how is it different than other water. We want to be able to describe two major types of ocean currents. And then using that information, we'll explain how the ocean is able to regulate the Earth's temperature and why the ocean is important for keeping the Earth at a relatively stable temperature. And then lastly, we want to identify the major locations of fresh water, the two biggest locations of fresh water. So we are going to work to try and identify those in this section. All right, so let's start off and cover the first part of this. So we want to look at the major processes of the water cycle. So we first need to be able to say, what is the hydrosphere? All right, so the hydrosphere is all of the water on or near Earth's surface. And water connects in the hydrosphere through a process of the water cycle. It includes water that is in lakes, rivers, wetlands, ice caps, soil, the rock layers under Earth's surface, the clouds, and everywhere. All right, so that is all the different places where water can be found. And I'm probably leaving some off there, but you get the idea that this is just all the different places on Earth where water can be found. And that's what we're talking about when we talk about the hydrosphere. All right, the hydrosphere has things living in it. It supplies water to different places. It transports water all over. It can pick up materials and transport them, like how we talked about erosion and sedimentation and things like that in the previous videos. All right, so we want to talk about the water cycle, and I have a little diagram here of the water cycle. It's got a couple of details on it, and I'll go over this and talk about what each one of these steps are. All right, so the first step of the water cycle is going to have to look at how this water is cycled from the ocean to the atmosphere and back to the ocean. So you should know the term evaporation, and evaporation is simply the change of a substance from a liquid to a gas. That's water. You let it sit out too long, eventually it dries up. Well, that's evaporation. There we go, plain and simple. Most of the evaporation that we're going to have on Earth is actually going to come from the oceans, and the reason for that is because the oceans are the largest surface area of water. It's just the biggest amount of water that's interacting directly with the atmosphere, so that's going to give the most amount of space for that water to go ahead and evaporate up into the air. Condensation then is the next step, and that's what's going to happen here. So condensation is when you go from a gas to a liquid. Well, if you look up in the sky, you can see that you've got clouds and things like that up there. Those clouds are not vapor. They are actually liquid. That's liquid droplets of water. They're tiny, tiny, tiny drops of water that are being blown around up at higher altitudes, and they're kind of trapped up in the air up there. So water vapor forms droplets on dust particles, which then form clouds. Those droplets collide to create larger and heavier drops. And eventually, if you get a high enough level of saturation there, you get big enough drops that are all colliding with each other, they will eventually form clouds and come back as rain, or a number of other forms of precipitation. All right, so when we're talking about the water cycle, it's very easy to say rain. Okay, rain. We all know rain. Rain's water falling from the sky. Great. But we want to make sure that we're using this term here, precipitation, when we're talking about the water cycle, because it is all of the different forms of water that falls to Earth's surface from clouds. It includes rain, snow, sleet, hail, fog drip. I mean, fog drip. That's literally when you have fog and it starts to just condense water out of it onto surfaces and things like that at low altitudes. All right, these are all different ways that water gets back to Earth. All right. So those are the major steps of the water cycle: evaporation, condensation, and precipitation. And then when the water's on the surface, it can flow, it can move, it can be transported all around. Well, speaking of transportation all around, take a look at this. How many oceans do you see? Okay, how many oceans are labeled? You've got 1, 2, 3, 4, 5 oceans labeled. Great. How many oceans do you actually see, though? Like, do you see any actual barriers between any of these? Because there aren't. Because this is a globe. This is folded flat, so this connects to over here. There's not a bridge of land that covers up this whole way, and they left Antarctica off completely. So yeah, all of the Earth's oceans are actually connected as one giant body of water. So all of the oceans are joined in a single large interconnected body of water called the world ocean. The world ocean plays an important role in its regulation of the planet's environment. So this ocean water, let's take a look at it. Let's see what it's like. So I got a little graph down here. And the difference between ocean water is freshwater and freshwater is that ocean water contains more salts. Okay, even regular fresh water, like out in a river, things like that, it does have a small amount of salt in it. And a salt is anything that can dissolve into water. All right, so you think of table salt, but it's not just that. Now, most of the salt in the ocean is sodium chloride, same thing as table salt. It tastes salty as a result, but maybe if you've ever gotten river or lake water splashed in your mouth, you'll notice it has a weird minerally metallic taste. Now, you shouldn't drink that water because it can make you sick, but it does have some dissolved metals and salts in there. So salinity then is a measure of the amount of dissolved salts in a given amount of liquid. All right. And this right here is a measurement of salinity in parts per thousand. Okay. So what that means is if you have 1,000 molecules of water and a salinity of 37, so what that would mean is you've got a container that has 1,000 molecules in it. That's seawater. All right. 37 of those molecules are going to be salt molecules. That's literally what it means. Parts per thousand. All right. Salinity is lower in places that get a lot of rain or in places where fresh water flows into the sea. By contrast, salinity is higher where water evaporates rapidly and leaves salt behind. Okay. So here's where it gets a little interesting. Let's look at this map of the Earth. So if you look here near where the equator is, which runs along this way here, you'll notice you've got a couple of hot spots where you suddenly have a higher level of salinity. But look right here in the Mediterranean, you've got a huge level of salinity there. Well, the reason for that is the Mediterranean actually does not get as much fresh water there. They got a lot of evaporation that happens there because the climate is relatively warm. But at the same time, they're also not getting a lot of fresh water coming in, and you've got a very narrow space here for exchange. So you get a lot of evaporation. That salt content goes way up. It's so high that it actually affects the salinity here. So this is that salt that's flowing out into the larger body of the ocean here. And then you get a couple of hot spots here where you get high levels of evaporation. Same here. Then if you look farther north, so if you look at the coast of the United States here, you get a lot of rain along this coastline here, and this can actually drop that salinity. Farther north where you don't get a lot of evaporation because it's colder, you're going to have a lower salinity, and same thing down here in the south. And then again, at that equator, you're going to get this band going around where it's going to be higher salinity all the way around the Earth. And then you've got, a lot of rain through this area, and that's going to cause that there. So these are some different ways that salinity is affected as a result of just patterns of weather on the planet. All right. So the salinity is also going to have a little bit of an effect on the currents in the ocean. Okay, so stream-like movements of water that occur at or near the surface are called surface currents. So a current is just like a river that's flowing, okay? Except this is how large bodies of water are moving, all right? Surface currents are these patterns that you'll see of how the current gets pushed around, how the surface waters get pushed around on the surface. Now, right here, you have the Canary Islands, and you've got the northern part of Africa here. You have the equator that runs right about here. And what you'll have is you have this current where you've got this water that gets pushed along here and intermixes with this warm water here, and that gets pushed up the Gulf Stream here. So what you get as a result is you get warm water here on the coast of Florida and in the Caribbean. You get very nice, very warm water, especially in the summertime. You get warm water all the way up the coast of North America, up our east coast of the United States, North Carolina, those areas. They get lovely warm water. The beaches are nice to go to and swim in. And then that water actually gets pushed all the way up to the North Atlantic, and it actually helps keep part of Europe kind of warm here. So it is cooler here than it is in Arizona, but it stays relatively warmer than if you go across over to here where you're in Alaska here. So look, England is about the same north latitude as these parts here of Canada where it snows and gets super cold, but in England it doesn't get nearly that cold because they're being continuously bathed in this warmer water. Now it does snow in England, but it actually doesn't snow nearly as much. It's actually a very mild climate by comparison. All right, over on the other side though, look, we've got a stream-like motion of water here where the descending part of it is coming down through here through this North Pacific. So that actually circulates cold water along this coast. And if you've ever been swimming in California, you know that that water, like in San Diego or San Francisco or those kind of places, that water can be really, really cold. And that's the same thing here. You have these big circulating things, and this is moving around heat all around the surface of the ocean. These surface currents are largely driven by global wind patterns, and they can be warm or cold water currents. However, currents with warm water and currents with cold water do not mix very well. All right. So generally speaking, when you've got a warm water current and a cold water current, they'll kind of butt up against each other, and they won't mix super well. All right. And that's actually part of what keeps them sort of separated in some ways. All right. All right. You can also have currents at the bottom of the ocean. So deep currents are stream-like motions that flow slowly along the seafloor. So deep currents happen down in the deep. Hey, that's very straightforward, isn't it? All right, so deep currents form when the cold, dense water from the poles sinks below warmer, less dense ocean water and flows towards the equator. Okay, so take a look at this image here. So you get the warm water, that's the surface movement of some of the water. And you saw some of those currents, and there's going to be exchange of water across those. But then you've got this cold water current that actually flows more continuously. And so up here at the poles, you've got the water that's getting chilled and it starts to descend. It goes down and gets pushed along here, and you get some upwelling here in the Indian Ocean. So some of that water gets pushed up into this area. It doesn't have anywhere to go, and it gets pushed up to the surface here, and then it warms and starts to flow again. But some of it will go down, and there is actually a circumpolar current that goes all the way around here. There's a secondary deep ocean current that goes deep, deep, deep down, and it flows all the way around the planet, around Antarctica, and that keeps extremely cold water down there. Eventually, it reaches part of the Pacific Ocean where it warms up near the equator again and it rises. All right. The densest and coldest water is actually located off the coast of Antarctica. So there we go. And that helps keep the Antarctic current cold all the time. And that also does help bring up nutrients that get washed down to the bottom up to there. And you can actually get very rich, very productive waters despite being extremely cold. All right, so we want to look at the ocean as a global temperature regulator. So you remember how I was saying that the British Isles and some other places are aided by having the ocean deliver warm currents to them. Okay, so now let's take a look here. You can see that this is taken in August, so it's about as warm as it's going to get in the northern hemisphere. But what you can see is that you have a little bit of a change here. So you've got some very warm water up here in the northern hemisphere. This is the warm water that's going to feed things like hurricanes. But look right here. In California, you still have this cold water descending, even though everywhere else you see you have this very warm water. All right. At the same time, look over here on the coast of South America. You will have cool water that will come up there. Again, on the coast of Africa down here, cold water is going to bathe that area also. But on the other side, where you have the Indian Ocean here, where you have this warm water trapped, you get warm water over on this coast. So you have very, very different climates on either side of Africa, even though you're at about the same distance from the equator here. All right, so the local temperature in different areas on the planet is also regulated by that world ocean. Northern California, a lot of times will stay cooler in the summer than other places that are inland away from that. Certain places in South America is very cool down here. It's also kind of dry as a result, not as much evaporation. Currents circulate warm water, causing land areas they flow past to have more moderate climates. So right here in the Caribbean, you've got Florida. And if you have ever been to Florida or you know anyone in Florida or anything about Florida, the climate's about the same year round. I mean, it doesn't really get very cold in the winter. It stays in the high 70s, 80s, very similar to what it does here in Arizona. And in fact, a lot of times in a lot of places in Florida, it actually stays warmer there than it does in the middle of our winter here because it's so much water around it that that humidity actually traps some of that heat in. So what you end up with are places like the British Isles, warmed by the Gulf Stream. Again, you can't see that in this picture here, but in the winter months, this will stay warmer up here. It'll stay about this temperature as the dark, dark blue water, dark, dark blue color will descend in these other areas. But you get these pockets of warmed areas and cooled areas based off of this global circulation of heat. All right, so that's where I'm going to end this discussion here. That is some of the information about the global ocean, how it circulates temperatures, what we mean when we talk about salinity. Next, we're going to need to talk about the next part of this, where we start talking about some of the characteristics of water in different places and identifying, well, where's the fresh water on Earth then? So we can't drink the ocean, so where do we get our drinking water from? So that's the next part of what we're going to have to talk about. All right, guys, I want you to take care. You have a great day, and I'll see you soon. Bye.